So very good afternoon and a warm welcome to all the participants in the faculty development program on smart building design, ECT for net zero, that is jointly organized by NICT Academy and Department of Architecture and Planning and Mechanical Engineering at NIT Patna. And we are pleased to welcome our experts, Dr. Sandeep Arora from School of Planning and Architecture Bhopal. And Dr. Arora will be delivering a session on the important topic, that is climate data analysis and building design strategies, where he will share insights into how climate responsive designs supported by accurate data analysis and that is play a critical role in energy efficiency and sustainable architects. So now I call Subham Meena sir to briefly introduce the expert to the participants. Over to Subham sir.
Thank you so much, Ravi sir. And good afternoon, everyone. It is my pleasure to introduce our next speaker, Dr. Sandeep Arora, Associate Professor in the Department of Architecture at the School of Planning and Architecture, Bhopal. Dr. Sandeep Arora brings with him around 2 decades of experience in teaching, research, and consultancy, with expertise spanning sustainable urban planning, urban morphology, pace of solar architecture, design, and informal housing system. He joined SPA Bhopal in 2011 after completing his master's in urban design from Ball State University, USA, where he also gained valuable industry experience from 2007 to 2010. He earned his Ph.D. from SPA Bhopal in 2020 and has since made significant academic contribution through publications, peer-reviewed articles, and international conference presentations. Notably, he is the recipient of the Architectural Research Center's Consortium Professor Jonathan King Medal for Excellence in Architectural and Environmental Design, a prestigious recognition of his commitment to impactful research and design. In today's session, Dr. Arora will speak on climate data analysis and building design strategies, where he will explore how climate responsive design can be strengthened through informed interpretation of environmental data and its application to smart and sustainable architecture. Please join me in welcoming Dr. Sandeep Arora. Over to you, sir. Say, your voice is not coming.
Sir, you are unmute, but I don't know. Your voice is not coming. Maybe there is some error with your
Hello.
connection or something.
Hello, Subham sir.
Yes, sir.
Yeah, sorry, from my side, say some power is gone, so I'm disconnected. I hope you call the expert to the presentation.
Hello. Hello.
Yes, sir. Yes, sir. Now your voice is coming, sir.
Hello.
Yes, sir. Yes, sir.
Okay.
Yes, sir.
Okay, Shubham. Thank you. Thank you for a long and detailed introduction. Please let me know, Shubham, in case during the presentation if it gets disconnected. Okay.
Sure, sir.
Okay.
Sure, sir.
So I'll share the presentation. Okay. So I just share the whole screen, I guess.
Yes, sir. Your screen is visible to us.
Okay. So pretty much at the beginning, I would like to thank NICT Academy as well as Department of Architecture and Planning, Department of Mechanical Engineering at NIT Patna, and also Shubham, thanks for inviting me and giving me the opportunity to speak in front of the audience. Well, I assume most of the audience here is faculty, so probably a lot of things are well understood and we'll be able to talk accordingly only. So, when I heard about this invitation, talking about climate responsive design, and it is one of my area of interest. But when it is more concentrated on net zero energy buildings, I felt probably we need to differentiate between the kind of approaches that we have, as well as what kind of approach do we need when we are talking about net zero energy buildings. So with that approach only, I have prepared the presentation, keeping in mind that how we can highlight the idea, which is the main theme of this faculty development program. As I understand, it is 10th day, maybe not 10th day, but pretty much towards the conclusion of it. So a lot of things might have been discussed already by various experts. So substantial knowledge has been generated already. So I'll try to keep things brief, but at any point, if there is any elaboration required, please let me know, and I'll be happy to elaborate on the points. So I'll go ahead and start. As such, basically just a basic understanding of net zero energy buildings, and all of you by now are very good at it. Many of the sessions might have talked about it already, but at the crux of it, I think it is basically about those buildings which can produce as much as they consume. So eventually all the minuses and pluses, once they are balanced, we can consider this as a net zero energy building. In addition to many of the traditional building design approaches, normally when people are dealing with the climate and other things, there is a difference that we pay less and less attention to the renewable resources, and we are trying to take care of thermal comfort, trying to understand when we are deviating from the comfort zone, and trying to understand the data, climate data, and accordingly we analyze it and try to design the buildings so that we are comfortable. But I haven't seen much of the approaches, much of the discussions going on. How do we actually design as architects to enhance or to maximize on-site renewable energy generation? And that point is somehow missing. And especially in Indian context, I've seen many of the dialogues that go on. We don't touch much upon how architects can take care of this issue. I mean, of course, there are so many technologies which we'll talk about: solar panels, different kind of technologies, mono cells, poly cells, and other kind of things, and windmills. Several kind of technologies are there, but many a times it goes out of the domain of architecture. And I totally understand that today the audience is mechanical engineering and other disciplines also, but please allow me to elaborate a little bit more on the architectural side of it, considering myself, I'm anyways, because I'm going to talk about building design, and I come from the side of architecture, so I'll end up talking more about those issues and opportunities which are there for architects as such. But it is not a disconnected thing, considering the multidisciplinary nature of this field. It is all related. So overall, the emphasis on today's lecture is slightly on the building design part, but more on how on-site renewable energy can be taken care of when we talk about climate analysis and various tools for design. Now, as such, one of the very important thing when we talk about on-site renewable energy, one of the thing is whether there is unobstructed access to the natural resources. Depending on the current trends, the way people are developing these days, the buildings and the cities are developing these days, that becomes a very distant target, that you develop building volumes so that one building is not hindering the access of the other building in terms of sunlight, in terms of wind. It is not blocking it, or it is not changing the natural pattern. Most of the cases, every other development is changing the pattern for the previous design, the existing buildings, or maybe creating a new scenario for the new construction which is going to come up. So it becomes a difficult thing to say whether the design is actually taking care, that whether we are assuring that there will be unobstructed access to the sun, to wind, light, and these kind of things. Today's presentation, I will emphasize on solar access as well as light. Primarily on solar access, that takes care of, to some extent, it will take care of light also. Now, as such, there are so many building bylaws. They gave us access to right to access and many other rights as such, but we don't talk about right to sunlight or access to solar or access to sunlight as the fundamental rights of the individual. They are pretty much not considered. They are pretty much the secondary as such the current practices are concerned. Whereas in other countries, in many of the countries, there is a bylaw, which is in addition to the regular building bylaws, and that bylaw takes care of the solar access also. However, in India, it is still not that strictly enforced. But when we talk about it, our task is primarily to deal with the forms of the building. Ultimately, if the building form allows or it does not restrict the access to the next building, to the surrounding buildings, then we can say, okay, pretty much it is taken care of. As far as the form, the maximum form or the maximum buildable volume of the building is concerned, in India, our practices are primarily governed with certain bylaws, and those bylaws are basically MOS, FAR, height restriction, ground coverage. These are the primary things which are always given to us. And we try to do our part within that, and we know that what is the maximum envelope that we can design. So within that, but we need to question whether that is less, whether that is more, or does it really align with the solar access and other access to sun, wind, and light also? Or is it just about putting a volume which is not necessarily assuring the solar access? So that is the background of this presentation, and on those lines only I will continue. One of the news you guys might have heard about it, but it is not necessarily a news. Everywhere in any of the other city, especially with slum relocation projects, if you look around, you realize that many of the high density residential areas which are coming up because of various policies, various projects that we have for housing also. And the housing scenario is very different because the primary target is to get to the lower cost, get to the higher density, so that maximum number of people who are slum dwellers or who are in a weaker section, they can be housed. In an attempt to do that, we end up designing housing or some overall building volumes which are too high, too closely packed. And in such cases, it is very simple. I mean, one cannot expect that one will have solar access to light, access to wind, natural wind and natural light, morning light and evening light. It's very difficult scenario as such. So the issue is prevalent, irrespective of what city we talk about. This issue is prevalent, and we need to see what we can do about it. So today I intend to talk about two things. One is climate responsive design, but I don't want to highlight a lot on it because most of the audience, they are faculty, so they are anyways aware of. For years we have been studying climate data, analyzing it, deciding on certain strategies. Maybe depending on the local conditions, we prioritize certain strategies over the another, and then we come up with certain strategies of material, certain finishes, or certain kind of volumes, certain kind of infiltration or fenestration through the building, and number of strategies. So, but we are very much familiar with that. One of the least known dialogue, many times, maybe some of you are aware of it, but very few people talk about how are we designing the building forms, the overall volume, the shapes, so that the on-site renewable energy can be taken care of. So today I will talk about these two things only. I will briefly cover climate responsive design, just the basic principle of it, and then I will try to discuss net zero energy, availability of solar access in detail. So let's talk about the prevalent design process and tools. In climate responsive design, all of us are familiar. We start with one of the very basic classification of climate type, whether it is by NBC or some other system we follow, whether we follow the international system. Now this is an image of Köppen classification. Now there are several types of classifications. One can just pick as per their requirements, and it allows us to see what kind of temperature conditions are there, what kind of humidity conditions are there, what kind of rainfall conditions are there, and whether it is arid, dry, or whether the humidity is there. So there are several ways of describing what kind of climate type we are referring to. And this is the overall world map. If we zoom further into India, we can further see that there is a detailed version that tells us, okay, these are the different kind of classifications available for climate zones in India itself. And again, all of you might be aware of NBC and other classifications which we typically find in the books and all that. So that used to be a typical process earlier of identifying the climate type. But these days, with the software and other things, we don't worry that much about it. This becomes a dialogue only that, okay, this is the climate type, but all kind of data is available to us. There are so many file types. Pretty much ISHRE provides us data of various cities in India. So we can import data from that. We can just insert into any of the software, and software will take care of it. It will do the calculations for 365 into 24. So the annual hours, total number of hours, it will identify what kind of characteristic we have for that particular hour. So characteristics in terms of what kind of temperature we have, what kind of humidity we have. And based on that, it can give us a good plot of what kind of weather we have for this. So this is a very simple tool. Pretty much, I assume we are all aware of it already. This is a psychrometric chart. It allows us to compare the data of any place, the climate data of any place, with respect to the comfort zone. So just to quickly go over it, the one which is in the rectangular area shaded as green, these are the hours for which the weather is comfortable. Now beyond that, pretty much for all other hours, the weather is uncomfortable because this is outside the comfort zone. So we can use any of the software. There are several kinds of software which will do this task for you. So we can start to compare, okay, if this is a comfort zone, on the right of it, the temperature increases. So if data falls within this area, we need to do cooling. If it is on the left of the comfort zone, that means temperature is less. So at this point, we need to do more of the heating is required. If we go further up, because now the humidity increases and the relative humidity lines you can see going up here. So if the data falls in this range, that tells us that, okay, for this particular area, you need to bring the humidity down. So we need to identify some strategies for that. So normally we identify where is the clouding as such, where is the majority of the dots, where is the majority of the data falling. And as per that, we can prioritize certain number of strategies. So this is a typical process of using psychrometric charts. Based on that, we can make certain design decisions. This is another version. I'm just showing you certain clips from different tools which are available. I mean, we don't need to worry about the tools. So many open source tools are available, but it is more important how we decide on certain strategies. So I'm still covering the basic building design part. The net zero energy part I will move on to later. Now in this one, this is a version of the same psychrometric chart that talks about beyond the comfort zone. If the data is there, then what kind of strategy we need. So if this is the area where the data falls, we need to do natural ventilation. This is overheated area. So if this is where the data falls, we need to do cooling. If it is beyond it, we need to do cooling with further intense strategies. And after a point, it will go further beyond, and probably the air conditioning is the only option that we have. Similarly, as we go up, if it is too humid, dehumidification is very difficult as a strategy for passive solar architecture. Humidification is easy because we can add certain water features, certain ways of adding humidity. Any kind of evaporative cooling is easily doable, but dehumidification remains a challenge. So pretty much we assume okay, this is where we need to apply air conditioners and all that. If we go to the left of the comfort zone, we realize, okay, this is too cold and we need to do certain strategies like internal heat gains. That is what we find in hilly areas. People keep windows less, and they have the animals inside the dwelling, maybe on the lower floor, so that the internal heat from the animals or from other storage, from the heating or some fire, that can contribute to the living area also. Similarly, other ways of trapping the heat using greenhouse effect or some other things, using glass houses or sun spaces, different means by which we can add heat. Active heating, anyways, heating through mechanical devices and all that will become part of it. So this process has been very common to us. We have been referring to it, and for decades we have been following this when we want to design buildings. So this is not something new. So I'm also assuming that all of us are familiar with this process, and things are known to you already. So I will take it further. I'm trying to just introduce certain tools so that I can frame a background for the next work also. Now this is another tool, Sunpa diagrams. all the software, they also have psychometric charts and sun path diagrams inbuilt into it. That's how they give us various kind of plottings also. So sun path diagrams allows us to see where is the sun at certain point of time at a certain day. And then we can correlate sun path diagrams with the data. Suppose this is the data of Bhopal, pretty much because I'm teaching in Bhopal, so I have those slides ready. So I'm showing you those data only. But pretty much for all the cities, data is available. It's not a difficult thing to find. Now this chart, which is a 3D plotting of the temperature graph, we can see, okay, this much part is actually overheated. So on this scale, we have months, January, February, March, April, December. And then on this scale, we have morning to afternoon, then till night. So this chart itself tells us that, okay, this is the overheated period. These are too cold. So we can kind of correlate what's on the sun path diagram, and we can identify where is the sun when this is overheated. So this part has been plotted here, approximately, of course, but we can always correlate temperature wise where is the sun, and then we can make thoughtful decisions regarding whether we want to avoid the sun or whether we want to invite the sun. So invite or avoid depends on what kind of temperature conditions are there. So whether we want sun to contribute to it or whether we want to protect our space from the sun. So this kind of correlation and this kind of data correlation is one of the required things. Now we take it further. Again, certain tools you guys might have seen, Andrew Marsh and Climate Consultant, Ecotech, all kind of tools are there. Now this I wanted to share because we are seeing that this is the approach we commonly use, and in this case we are seeing that, okay, this study for this building shows sun is here throughout the year. This is where the sun is, and then shadow patterns one can study. Now, this kind of studies always highlight the building that we are trying to design. Now, that has been the approach for the most part. Even in tools, even in our classes, even when we are teaching, we are paying more attention to the building that we are designing. And we are rarely worried about the other gray parts of the building, other buildings which are surrounding it. We are not paying attention to that for the most part. But when we talk about net zero energy building, and when we talk about harvesting the available resource or on-site renewable energy generation, we need to first assure whether that renewable energy that we are talking about, whether it is available or not. So that is the idea. So we go on with the next part that I want to highlight, which is about net zero energy buildings. And this is an approach which I keep on suggesting in view of the highly dense and the new patterns of development. I tend to highlight more on this, and I'll be talking about solar envelopes today, so that we can relate that how one should design, how one should identify the limits, the volumetric limits of design, so that the access is not restricted. So overall, let's look at it again. We want to highlight net zero energy buildings. So on-site renewable energy becomes very important. As far as design is concerned, other than the technologies, of course, but as far as architectural design is concerned, our tools are basically the volume, the material, the form of the building. And then there are certain laws that we are following. So of course, building bylaws are there. So we want to ensure that if we want to use on-site renewable energy, then one building is not obstructing the other. Now this little rendering that I have done right here, that is basically a SketchUp rendering of volumes which are permitted by the bylaws. I have used Bhopal, Madhya Pradesh Bhumi Vikas Adhiniyam just to show it. Now I'm not saying that this allows all of this development, but the bylaws, they do allow close packing of these buildings. So if we just go by the basic laws which are there, so they allow 6 meter to 6 meter, 7.5 meter spacing. And then of course, if we look at the total FAR, we might have to remove some of these blocks. That is true. But the in-between spacing bylaws very much allow. But when in-between spacing is very less, it is going to obstruct solar access for the next building. That is one of the unfortunate scenario that we have with the building bylaws. So we'll look into it further. Now, if we say, if we look at the concept, which I want to highlight today, is concept of solar envelope. Now, as such, Ralph Knowles, he is a researcher in USA, and for years he has been talking about how do we design volumes, or what is the maximum envelope. Along with that, what is the shape of the envelope? If you design within that, the building is not going to obstruct the solar axis of the other building. Now, if we compare these two forms, right here, every block is going to block the solar axis of other building. But if we start to compare these slanted, inclined, sliced volumes, now these angles are to be identified. I will talk about the process of identifying these volumes. But if we use this process, then each of these buildings is not going to obstruct the solar axis, sunlight axis of the other building. Now, I don't intend to say that it will not block access at all. It will block access, but probably not during the time frame when we want to have the solar access. So of course, early morning, evening hours, when the sun is bent down, when sun is very low, then one building is going to cast shadow on the other building. It is very difficult to avoid that. So, but we need to also understand whether it is required. Should we say that building should not cast shadow on the other building at all? Or do we say maybe not in the morning, not in the evening, but when the sun is at its peak, maybe morning to afternoon, then before evening, if that sun is available and one building is not obstructing the solar axis of other, then that sun can be used for solar panels, building photovoltaic, building integrated photovoltaic, or similar dialogue can happen about the wind also. Right now we are talking about solar axis, but certain kind of volume will assure that these volumes are not obstructing the solar axis of the other building. Now that is the idea, that is the basic idea. Now this is not taken care of, this is not discussed in our building bylaws at all. Now, I talked about, of course, there will be times when it is acceptable to say that one building is shading the other building. Now, of course, in the morning hours, in the evening hours, sun is very low, so it is going to have a shade on the other building. It is difficult to avoid. But this is a color-coded chart that shows that solar intensity, when we are getting maximum solar energy. So if we study this, we realize that 75% of the normal radiation is received between 9 a.m. to 3 p.m. So if we design an envelope, if we design a building volume so that it does not obstruct the solar axis of the next building between 9 a.m. to 3 p.m., then we can say, okay, we have not limited the solar axis of the next building. So with that idea, I have developed this further renderings and further calculations. Now 75% is not a rule. One can do this exercise for 80% also. One can do this exercise for 70% also. It eventually comes down to what angles are acceptable to us, because it is basically trade-off. You are going to lose the volume of the building, and if you totally want to avoid that, no, it should not obstruct. That will be very difficult to design. But the idea is between 9 a.m. to 3 p.m. throughout the year, 75% of the radiation is available if we design as per solar envelope. Now, again, just looking at the tools, we can use this tool. I'm assuming most of you are familiar with it, but these lines, these are day lines. So one can locate the dates. So this is June, July, August, September, October, November, December. So lowest one is December. The first one is June itself. Now, so all these are days, and all these serpentine 8-shaped lines angles. So it is basically about at what angle is the sun at a particular time of the day. So once we know that, okay, between 3 p.m., between 9 a.m. to 3 p.m., we don't want to block the sun. So we can identify what is the angle of the sun. Once we have identified the angle of the sun, that it should not be blocked, now we can start to slice that rectangular volume so that the rectangular volume becomes a pyramidal volume, and that results into a shape that if we design within that, it is not going to obstruct the sun for the other building. Now, briefly covering the process of it. Now, in winters, we know that, okay, in winters, these are the lines. So if you are looking at 9 a.m., so in the winter solstice, 9 a.m. is right here. So 9 a.m., and then, so this is morning and this is evening. So this is the zone in winter sun where that sun is available between 9 a.m. to 3 p.m. So we are doing this study for 9 a.m. to 3 p.m. only. And then we are looking at summer sun. So again, we are looking at the sun, which is at 82 degree, which is at the highest. Now this data is for Bhopal. I have mentioned it already. Depending on the location, these solar charts will change. But it is very easy. All the tools will allow you to get these solar charts. You just need to enter the latitude, longitude, and they will give you that. So we are trying to identify where is the sun between 9 a.m. to 3 p.m. throughout the year. That is basically the crux of it. So if you're finding it difficult to just see what is going on, we are just trying to find out where is the sun when we are wanting to have this access of the sun, solar access, between 9 a.m. to 3 p.m. We don't want to block any of the sun between 9 a.m. to 3 p.m. So if we try to plot that location of the sun, this is the zone of the sun. Sun is right here when during this period between 9 a.m. to 3 p.m. So this whole sun, we want to ensure that in our designs, in our building volumes, this sun is not blocked, because if it is available, then only we can use it for solar panels, ensuring that solar heating or some other kind of resource, we can actually use it. Now, of course, I'm not digging into other things regarding overheating and having the double roof or protection from the sun, because that part is, of course, there is a balance between these two dialogues, but that part is something very well understood in India. We have been doing that for decades now, regarding where is the sun and shading devices and second roof and evaporative cooling, and a number of strategies are there. But this is something where not much attention has been paid so far. So if we continue with this dialogue, we can assume a scenario. As per building bylaws, let's say this is the road. Okay. Now, if this is the road, on both sides of the road, we have the buildings. Initially, the building volume that is permitted by the building bylaw is this much. But this volume is actually blocking the morning sun for the next building. I hope you all are able to follow. This building is going to block, this portion of the building is going to block the morning sun for this. Now this portion is going to block the evening sun for this other building. So for every other street, we have this issue that the buildings on one side is blocking the morning sun for the building on the other side. And in the evening, the reverse happens. The building on the other side is blocking the evening sun for the building on the former side. So ultimately, morning to evening, this phenomena is going to happen. So we need to know that, okay, if we want to slice it, if we want to take away a portion of the rectangular building, at what angle do we do that? Now, these are the angles which I was showing you on the sun path diagrams. So if we take the sun path diagram, we take that angle and slice the building at that particular angle. That tells us, okay, this much portion can be sliced off. And if we slice it off, it is not going to block the solar access for the previous building. Same thing on the other building also. So we continue this dialogue further. Now, for the winter sun, we talked about morning sun and evening sun, but what about winter sun? In winters, the sun bends towards south, all of us know. Now, if the sun is bending towards south, every other building, if they're closely packed, they are going to hide the solar axis. They are going to obstruct the solar axis for the next building. So in our residential areas, we always see that in winters, some of the balconies, some of the windows, they never see the sun. In summer, they do, because sun is high up. So some sun is going to get there. But especially those balconies, those windows which are facing south, if there is a building on the south side, the building which is in front of it, it totally blocks the solar axis of it. Now, of course, it is required for heating, for a nice, sun is required. Sun, we can't say sun is not required. Sun is basically the element that we say that is what defines the rhythm of our life. I mean, we wake up in the morning, plants, trees, other animals, the whole life that flows with the rhythm of the sun itself. Even there are two kind of rhythms if we talk about. One is seasonal as well as one is daily rhythm. Now, both of the things, that is what we're talking about here, that keeping in mind the daily sun as well as the seasonal sun, we are not blocking the desired sun. That is the idea. So we know that, okay, the winter sun blocks the southern portion, So we need to take off some of the southern portion. We need to slice off some of the southern portion from the building so that they do not obstruct the sun that should reach the north face of the next building. So that is the idea. I hope everyone is following. We are basically talking about that the volume of one building should not block the other sun. When it is a rectangular volume, it does block. But when it is pyramidal volume, it allows. But pyramidal cannot be, say, just like pyramid of any other kind of pyramid, we will slice it off at random angles. No, we need to study at what angle, where is the sun, and then we need to find that angle and then slice it accordingly. So this is the process that we are talking about. So from that rectangular block, we slice off the portions that we just saw. So we take these portions away, and that results into the remaining rectangular block. And then we are kind of defining it and taking further into kind of buildable volume. So that is the idea. Now we are calling it solar envelope. So in a way, this is an envelope. If we build within this limit, it is not going to obstruct the solar axis of the next one. So it is highly technical as such. It is all calculated, but at the same time, that calculation is required. Now, it is not a theoretical thing that I can just tell that, okay, this is the rule and you do it. It has to be done side by side. It has to be done depending on what kind of bylaws are there, what kind of spacing is there between the buildings. At the same time, the orientation of the site will also make a difference. At the same time, the location of the building will also make a difference, because sun path diagram will be different for all kind of different locations. So things are technical, but it is, I mean, we are into this century where so many kind of tools are there. So we expect that we are also capable of handling this level of complexity and design accordingly only. So this is just a version of, on the left hand side, we are seeing what is permitted by building bylaws and what is permitted by solar bylaws. Now, it is not a technical term. I'm just referring to it so that we can have a dialogue about solar access. So these volumes allow the solar access, whereas these volumes restrict the solar access. So if we say, if you want to generate a building form, I have applied this on a residential scenario, because we talked about residential in the beginning only. So I've applied it just to illustrate the idea further. Normally we have residential developments. Let's say we take residential flatted developments. One of the very common typology is we'll have stilts on the ground floor, and after the stilts we'll have multiple number of floors, but then most of it is rectangular, or there is no difference between the floor plan of the ground floor and the floor plan of the upper floors. They are just repetitive, same floor by floor by floor repetitions. Whereas solar envelope demands that on every floor, the design is different. On every floor, as we move up floor by floor by floor, the tapering happens, because the volumetric limits allowed by the solar envelope are actually pyramidal in nature, that we saw, because we are slicing at angles. So it is going to result in pyramidal shapes only. But when we have pyramidal volumes, then we realize that, okay, for different floors, there is some kind of stepping, recessed form which is required. Of course, we can't just design everything built, but we can step it, because as far as the gravity and economy of working with column beam structure, those kind of details will come. The economical way of doing this will be to step the volumes. Of course, there are a lot of other challenges which are going to come up with it. That's why we are saying that it's not an answer as such, but it is one of the concerns. So one can see there is a lot of terrace area available. So much of the terrace area is available because we are stepping the volume. But when this is the terrace area, it is also the terrace area that we talk about solar for solar panels. So if it is about installation of solar panels, rather than seeing this as a constraint, we may start to see this as an opportunity, that different occupant wise, different occupancy patterns, if we see, different floor areas, different terrace areas can be assigned to people, and then solar panels can be installed on this, rather than just one flatted development. So we are looking at this just for the sake of explaining. I have modeled it as 3 meter by 3 meter cubical volumes, saying that it is a 3 meter by 3 meter room. So as such, it is just a representation. Okay, this is the common corridor, and on both sides of the corridor, we have flats on both sides. But idea is to see what kind of form eventually it will generate if we go with the idea of solar envelope, what kind of forms it will generate. So it is a task. Of course, designers will have a tough time. Builders are probably not going to like it much because of the economical constraints, the cost constraints, and repeatability and modularity is one of module is still there, but repeatability is one of the things that people love for the sake of economy, for the sake of ease of doing. For those things, repetition is very good as such. But this kind of scenario, this kind of dialogue wants us to design uniquely for different floors. So that becomes a challenge. That adds a complexity to our profession. Now these are some studio assignments, some studios conducted by Ralph Knowles. Ralph Knowles, as I mentioned already, he's the one who coined the idea of solar envelope, and we are discussing that only. So Ralph Knowles, on the left-hand side, for a gridiron pattern, he developed one of his students. It is part of the studio exercises. So some of the students developed that, okay, these are the volumetric limits. These are the angles within which the development has to happen, within which we are to build. And if we build it, it is not going to obstruct the solar access for the other one. Now, when we translate this into a detailed design, now you can read that nature of it. You can clearly read the stepped version of the housing. Now, it does not appear like a typical kind of housing because we are used to seeing housing which is just copies and copies of the same floor plan, floor above floor. But that's not the right way if we want to talk about solar access. So now this volumetric limits translates to detailed design. Now one can read all kind of steps, all kind of slopes and angles as we see the detailing of the volume. Now the previous one, now this one that we saw, it is very much on a gridiron pattern, so it is comparatively easy to do, but it is not always the case. So at times the solar envelope and the volumes, they are to be calculated accordingly, and then they give us pyramidal volumes, but not so simple. So one can see that overall this is the volume which is the solar envelope volume, and when we detail it out, we realize that okay, these are the kind of housing patterns, these are the limits, again with steps and slopes taken care of, and these are actually the translated version, the detailed version of the housing on the left. Again, these are studio projects only that I'm showing you right here. Another version, and we can again read the pyramidal translation into stepped translation as we see the detailing of it. Not necessarily residential only, one can start to look at other kind of constructions also, but it's basically about the limits of the solar envelope. It doesn't have to be residential or the other. Again, another version we can start to read, rather than a rectangular one has to manage the step nature of it. So that is visible here. Again, one of the commercial project where the volume in the white, it is showing that this is the limit, and then it is a detailed version of it. Now this kind of study is rarely missing when we are talking about it. Now that is in a way, I think primarily it is more about the awareness. At the same time, it is about the complexity of it, and it is kind of challenging how much we are aware, how much we know that how to take care of this problem, and how much we are aware of ways to manage the sun, identifying with that difficulty, and making decisions accordingly. Now, the study that I'm talking about, what I'm showing you is basically we did some classes here only in SPA Bhopal, and we used various limitations of solar bylaws, and the students studied various projects here only, and they kind of redesigned those projects, not in detail, but only the volumetric wise. They commented in an illustrative manner. They commented on what way should we design. So Madhya Pradesh building bylaws, they talk about spacing such as 7.5 meter. They talk about MOS, front, side, rear, all these, and they're probably not much different than other places, other than the metro cities. To a great extent, for the similar scales, they are similar. At the same time, what kind of MOS and what kind of other features they allow. At the same time, another problem is none of our bylaws take into consideration what to do when your plot is oriented north, south, east, or west. So orientation is completely missing. So it is the same thing whether the plot is oriented east or plot has an opening towards west, north, or south. bylaws do not talk about orientation at all. They only talk about front, side, and rear. That totally goes against the idea of sun. And when we are talking about climate data and deciding a form accordingly, that clearly says that bylaws do not take care of it. Now, I'm not trying to criticize bylaws here. I'm just trying to say that this is something that on our own probably we have to take into consideration. Bylaws, it is very difficult and it is not possible also to have a complete compendium that talks about all kind of orientations and then have bylaws for it. It is rather some kind of tool, some kind of software that we need, that okay, bylaws are there, but as per your orientation, as per your given specific conditions, certain building volumetric envelope can be identified. So it's not a the idea is not to criticize the bylaws, but to highlight that as architects, as designers, we need to take care of this issue so that we do not abstract solar access. Now, at the same time, there are more issues because we have sliced off certain portion of the box volume, which bylaws permit us. Bylaws give us certain FAR, and of course, everybody is going to want to use that FAR for economic purposes. Now, as per the studies, the FAR we cannot achieve if we go with solar envelope. The FAR is much less. So we need to increase at least 1.3 times the site. We need 1.3 times larger site to achieve the same kind of FAR. So this was a kind of comparison just to count that, okay, how are we doing on FAR part, the profit part, or the buildability part, floor plate as such, when we talk about solar envelopes. But solar envelopes do restrict or are not probably economically that fruitful, that good when we talk about in comparison to the building bylaws. So overall, just certain observations which I would like to share that one thing is, if we go with these pyramidal volumes, if we design for solar access, then the floor wise repetition goes away. We cannot repeat the same kind of floor plans that we have. That is what in industry we are very much which is very much preferred for the sake of economy, for the sake of easily doing it and working and making of it. At the same time, solar envelopes, because of its pyramidal shape, it gives us receding stepped profile that leaves us with a lot of floor area, a lot of terrace area. But terrace area, we need to probably have different ways of looking at it. Terrace area, at the same time, rather than seeing it as a terrace area only, we see that as a floor, as a space that has the potential of harvesting the sun energy. And then number of ways we can look at that, in what ways we can harvest the sun energy. At the same time, in addition to just saying this, we need to have certain inclusions. For example, there may be times when this will result into overheating. Now, things like certain attachments on the roof, they can be attached, at the same time they can be removed. So certain things can be there in summer, but things can be removed in winter. That we have to figure out, whether it is a temporary double roof, whether it is some other kind of device, but it is not one way or the other. We have to find a balance between whether we are protecting from the harsh sun or whether we are utilizing the harsh sun, because what we are protecting from is, of course, it is overheated. We do care about glare, but overheating is a bigger culprit. If we look at the overall data, if we look at the solar gain from north, south, east, west walls and compare that with the horizontal, by saying horizontal I mean the roof part, you will realize that the roof is much more a bigger culprit rather than north, south, east and west walls. So what we do on the roof makes a lot of difference. So at the same time, we know that, okay, roof is there to harvest the solar energy, but it may be less useful. It may be less useful in certain cases, but that is where the idea is there, that you have certain certain installations on the roof that can be detached and attached. So part of it becomes flexible over time. Another observations with these things, financial objectives are going to be compromised. Builders are not going to love this because of the unique floor plans, unique changes, lesser FAR. These issues are going to have, but if we look at sustainability, if we talk about energy gain, if we talk about harvesting energy, Those things are anyways these days for past few decades, they have not been the priority of the developers. But now things are changing. Now people are moving towards green ways of living, or living with the green idea as such. And solar panels, we look around most of the residential buildings, many of the residential buildings in any of the average city, they do have solar panels installed on the roof. Because of the cost of it, things have changed drastically from past 10 years. And every other building, every other institutional building, I'm sure at your institute also, at different institutes, we see that solar panels are installed. So things have changed drastically, and opportunity for harvesting the horizontal surfaces, the roof surfaces, they are going to be seen as a fruitful opportunity. Now, one of the thing is, with these kind of designs, unique layouts are going to be a problem. That is more of a task for architects. And we are also somehow trained over the period of time by copy and mirror culture also. And I'm not against it, but at the same time, with the idea of solar panel, this doesn't work much. So if we, not solar panels, with the solar envelopes, if repetition is there, it has many benefits. Of course, that's why modularity is a big dialogue here. But at the same time, when we are talking about designing so that the solar access is not obstructed, we have to go with the pyramidal volumes rather than the rectangular flat boxes. And also the development will have lesser density, so it will be difficult to achieve the same kind of residential density, especially for high density projects such as slum relocation projects, the image that I was just showing you a few slides back. In those kind of cases, it will be very challenging to, how do we get the same number of units when we are designing for economically weaker section in that limited area. So there are questions, of course, but the answers are to be probably achieved in future. But it does not, I'm not saying that this is an answer, but density is something which is a challenge still to be addressed. But again, when we are talking about net zero energy, harvesting the energy of the sun, this is one of the scope, one of the very important scope. Now, architects are going to have, or they need to have, higher order design skills. So I have not seen uh, these days people designing and talking about the idea of solar envelope, whether they're slicing every other building, keeping in mind, even at thesis levels, we don't see it. But probably eventually we will gain that complexity, and we'll require that in future. If we talk about profession as such, we need to get our drawings cleared by municipal corporations and other formalities, and so many regulations are there, and we need to get clearance in terms of building bylaws are followed or not. Now, even urban local bodies, even municipal corporations, architects, they are not yet trained enough to design the solar envelopes, because that process as such, it can be started, it is there, but the capacity building will remain a challenge. So of course, as such, it is very easy for me to say that, okay, this idea is good, this allows us to harvest the on-site energy, but at the same time, it is a challenge that how can one do the required capacity building so that people can engage into an idea. But with this hope, pretty much in future, probably as we become more learned, as we become more capacity wise more sane, we'll be able to deal with these things. Well, that was my short presentation. Shubham, with this I would like to end, and I would like to discuss or have any questions if there are anyone who has questions. So Shubham.
Thank you so much, sir. Participants, the platform is open for question answer session. If anybody have any question, please you can ask. You can write into a chat box also, or you can ask a question directly to our expert speaker also. If anybody have any question, please you can ask.
Hello, sir.
Yes.
Have you proposed or discussed with NBC revised committee with this idea?
Yes. My screen is visible, so I will quickly share one file, the proposals that we have sent. Also, it will allow people to see a little bit more. Just give me, okay. Now, I did not share it because I just felt this will be more science and more calculations and all that. But I'll quickly share just information directly relevant to the question. So right here, just give me a second. I'm scrolling through that table. Actually, we made a certain set of bylaws, and we call those bylaws solar bylaws. And those bylaws we shared. But again, the idea is there, of course. But one of the issue now right here, we have proposed a set of building bylaws, paired set of building height and minimum open space. Now, these are basically the bylaws proposed for solar access. So if somebody follows for different kind of road width conditions, so it is just another version of what Bhumi Vikas Adhiniyam, the building bylaws, they give us. But we have said that, okay, as per existing bylaws, front MOS, rear MOS, side MOS, they are there. But rather than that, what should be the combination of building height and minimum open space as per the solar envelope? So these are the figures, and we have proposed, of course, they are lesser. So they are much less. So if we go with the idea of solar envelope, the volume which are being built today, they will not be permitted. But yes, right here, these bylaws, they are trigonometrically calculated depending on the angle, because there are triangles and angles. So trigonometry is the only way to go about it. But yes, those have been detailed.
So have you calculated have you compared the solar gain between these type of building typologies due to the solar radiation?
Basically, this study is more about the availability and designing the building form as per availability. Now, whatever solar gain is there in terms of horizontal, that same solar gain will happen here. In this work, the idea is one building do not block the solar access of the other. So with that intent, if we compare this version with the other, pretty much this design will have, these kind of designs will have the solar access of a plane area or horizontal area. That means between 9 a.m. to 3 p.m., no solar will be blocked. So yes, not mathematically calculated, but the idea is that only it is pretty much the same, because we are talking about not blocking it. I hope that marginally answers the question.
Fine.
But yes, I understand if you're talking mathematically, no, we haven't compared.
Yeah, fine, sir. Have you thought about in this way, blocking these solar direct radiation will affect the heat gain to the neighboring building, right?
Yes, yes.
So if the effect, if the neighboring building is getting less heat gain, it will obviously use less energy.
Yes, but we are talking about harvesting the on-site. I totally understand that it will use less energy, because we are talking about the heat gain. That's why I said that we have to do a balance between protecting the building as well as inviting the sun. So protecting the building and then inviting the sun, one has to design considering the balance of it. The first part I skipped because most of us are faculty here. So we have been, I mean, in our bachelor's course also, pretty much in all architecture courses, we talk about starting from the second year only, we talk about how to design buildings so that the overheating can be avoided, the heating radiation can be avoided. But we do not talk about how to allow the radiation and then have the solar panels or other opportunities to be able to take benefit of it.
Okay. And have you considered the other bylaws permitting this skyscrapers which are located like far from this proposed site? Have you considered the shadow of that skyscrapers or natural topography?
It will apply to all of them. I mean, if we can take a site and then we look at all of them, we only need the FARs and all that. Now, the study that I was showing, or the things that I was showing you, these are basically about the residential developments and the study that we have done in some of the cases in residential developments of Bhopal. We don't see, I mean, in those cases, not much of the high rises were there. But let's say there is a case where there's a high rise building next to it. Now, idea is about that high rise building itself should be designed it in a manner that it does not obstruct. So if high rise building cannot be designed like a pyramid, so I understand the concern. But then the high rise building should have the vacant area around it so that it is far from the abutting buildings, far enough that it does not block the solar access. So it has to be done case by case basis. It has to be individually done if there is a high rise building.
What are the other challenges you faced while creating this? What like other critic opinions?
For the most part, there are the challenge that we have is that even I mean, we are discussing, but it's not a straight away answer. That depends on the skills of the designers only. That is the balance between allowing the solar access to come, at the same time avoiding the heat gain, overall heat gain. Now that balance is one of the biggest challenge. How are we deciding? How do we design so that we don't get overheating possibility? At the same time, we allow the solar access. Now that is where I was saying that it has to be a mix of climate responsive design of the individual building, at the same time overlapping it with the solar envelopes of multiple buildings. So there are two scales. In one scale, we have the individual building. On the other scale, we have the groups of buildings. So at both scales, we have to deal. Now, this is a challenge that in design, this kind of adds to substantial complexity. Even when we are teaching in classes, this becomes a substantial difficulty level, and students tend to get bogged down by other objectives in design. They have the program, they have other things, and then this complexity they tend to avoid. So that is one of the things in teaching as well as in practice. This thing is one of the challenge that is to be resolved.
And my comment is, as I think for existing built up area where the layouts are already formed and few of the buildings constructed,
Yeah,
you can't implement these bylaws. Like
right.
any new layout, like in new built up area far away from the city, like
Yes.
retirement village, we can opt for this.
Yes, it is a very important observation. Depending on how much is already built, the idea that we are talking about, it may not be just very easily applicable. If something is already built, then probably we will not get that pyramidal volume. Even certain portion of that pyramidal volume will again go away. So yes, depending on the conditions, it is. I mean, this dialogue as it talks about newly developed areas, but with losing certain portions in existing buildings also, it can be applied. But yes, all of the volume cannot be totally applied. But very important, very good points raised by you. Nice.
Sir, your design is okay. Slanting the building is okay for the cold climates, but in temperate zone, have you
Yes.
calculated the air conditioning load after slanting and with horizontal or vertical one?
No, sir. In this case, what we are talking about, the slanting building is not being slanted. Building is basically being stepped. The slanting volume is the theoretical volume. So what we are seeing is the slanting phase, that is the maximum theoretical volume. But when we are designing building within it, it is horizontal, vertical stepped formation, and with
That's
total
okay.
Yes.
That's okay. I am talking about the air conditioning load in temperate zone.
Yes.
With horizontal one or with the normal buildings without having any slope or slant at any floor or whatever it is, and the normal one as you designed accordingly, how much air conditioning load increases in temperate climate?
No.
Cold climate, it's okay. Slanting is okay. It requires
Yes.
solar resistance.
Yes. It will have much more air conditioning load. That's why I was mentioning that it is part 2 that I'm highlighting. Part 1 is basically the shading and the shading which will be required. So climate responsive design of the individual building is one thing, and then the solar envelope is about grouping of the buildings so that the climate can be taken care of.
I think we can't decide like it will be more load or not. We can design particular building structure, like if it is stepped, the stepped nature will allow more shading of the building. So we should customize the design and analyze it with due software or not something. So by then we can come to some conclusion.
Yes, yes.
Thank you, sir.
Thank you.
Any other participants have questions?
Sir, my question is, what are the key consideration when determining the height and minimum gap between the street to maximize the inclusion of solar rays or solar access in urban areas?
The key consideration is the morning sun, the evening sun, especially the winter sun. The idea is not to block the winter sun. So we map what are the angles when the sun is low, because sun bends towards south. So the angle of the sun, that is what defines the solar
Can
energy.
any type of window design can help the
Of course, let's say we are talking about that the heat gain will increase. Now, on certain shapes, on certain angles, if the heat gain is increasing, in that case, certain kind of window shading device can help.
Sir, we get a question in chat box from
Yes.
Divit Singh. He asked, how do we keep in mind that the economic constraint while considering the solar part and volume may cause many economical losses?
Yes, yes. That is what I mentioned in the beginning only, that this does not necessarily align when we talk about the economical aspects. As per the current trends that we have, we want to build more, and building bylaws also allow wanting us to build more. But when we look at the solar envelopes, the volume, we lose substantial part of the FAR. So economical constraints wise, yes, it is for the same site, we will get lesser volume that we can build, and that clearly means lesser saleability. So if we are talking about flatted development, lesser saleability of flats will be there. Shubham,
If anybody has any more question, please you can ask. Otherwise, we will going to conclude the session.
So this solar access, other than this for this renewable energy, we can consider this solar access for human relief and vegetation, like solar access for vegetation also.
Yes, yes, of course. There are several things. One can think of some kind of greenery on the roof or certain activities which are there. But just now, one of the participant, they were talking about in the cold climate it is okay. Of course, in the cold climate it is very much receivable, but in hot climate like in India, it is comparatively lesser invited a concept. Now, for solar envelopes, solar panels, it is very much easily acceptable. But for other activities, if it is cold climate, yes, outside sun activities, those activities, it can be used. So yes, somebody can have green area, somebody can have growing food, somebody can have some activities on the terrace, because a lot of terrace spaces are created when we try to build volumes according to solar envelopes.
Okay, thank you.
Sir, we have one more question. Can
Yes.
private shape design be effectively integrated into dense urban environment where space and zoning restrictions are a concern?
Yes, I mean, I've been raising this point in the observations only, that when it is dense urban environment, pyramid-shaped designs, we are going to lose the FAR. That is the same issue. So we started talking about highly dense housing, and primarily in case of slum relocation housing. In those cases, it is very difficult to achieve the same kind of FAR. So if we talk about effectively integrated, we have to see what is we are heading to. By saying effectively integration means, is it about we will consider it effective if economical constraints are satisfied. Yes, of course. In that case, yes, same kind of economic constraints will not be satisfied if we talk about it. So it really depends upon effective integration, in what way we are heading. Yes, economic wise, it will not have the same kind of comparison.
Do we have more questions, or we should conclude the session?
Sir, I just asked to sir, it is not a question, but just about to building like a pyramid structure, how to aware the people? People are in Indian context, they are using the maximum space. They are not going to step-wise building. So
Yes.
how to aware people this step-wise building is helpful for their health also, because maximum solar light is there. Because currently in present area, my present area, I can see there is number of building with the minimum street gap. And in the first and second floor, there is a no sunlight and people are affected many diseases. This is the main reason they are concerned with. The doctor said you are in your areas, you are not in the sunlights. So
Yes.
this step-wise building is how they, people aware we according to the Indian context. Indian people are mentality different thing.
Yes, yes. So of course, it's a very good question. I don't have a upfront answer for it, but I would assume that if something comes into building bylaws, that would be the easiest way to take care of it. Now, building bylaws, it is very easy to say that it should become a building bylaw. But if we look at the application of building bylaw, any kind of complexity will present so many challenges. But at least, let's say, building bylaws take care of one constraint, saying that the winter sun should not be blocked. So if the winter sun is not blocked, that will take care of many of the issues. So basically, it is the southern corners of the building that block the winter sun of the next building. So if the building profile is sliced off from the southern corners, it will allow the solar access for the next building. Now, these are the similar things. I mean, certain minor things can be started in the building bylaws, or then other than that, it is capacity building of the architects, like today's presentation only, or through academics only, we can start to raise these points. But yes, it's true that people are facing the issues. The difficulties are being faced by the people. Many of the people, they don't get to see the sun throughout the year, especially in residential developments.
Yes, sir. Thank you, sir.
Sir, Shubham, sir, which city you're referring? That
in this dialogue, I'm referring to the Bhopal only.
No, sir. Shubham Meena sir said.
Okay, fine.
In Patna city, sir, we are just talking about Patna city, but you know, but even our one of colleague is facing some issues. His residence in first floor, and the
Yes.
buildings are in very narrow streets. So that's why the one of physician is getting that points, and
No, actually, Patna is in composite climate, right? It's in hot only, right?
then this question is related with designing parameters, because people these days the buildings are constructed in maximum. The people are thinking about the construction, not the proper sunlight in the buildings.
Okay,
So,
even it is in composite hot climate zone, they're affecting because of this dampness in the rooms and all diseases.
Yes, and it is not a very difficult thing to deal with. Only, for example, in rainy season, at least one should see the sun. Now, normally in the residential development, we will have the same kind of layout all around, north, south, east, west. Now, south people will get the sun in winters, of course, but north faces are something that do not get the sun throughout the year. Only in summer, in the morning and in the evening, they will get to see the sun. Otherwise, for most part of the year, the sun will not be there. Now, this is not that difficult a task for the designers to handle. It is basically about orienting the blocks right. So this is doable, but again, this awareness needs to be there, and that has to be an intent regarding that design. So the intent is required.
Thank you so much, sir. Now we should conclude the session. We have just concluded a deeply informative and forwarded thinking session delivered by Dr. Sandeep Arora, Associate Professor at SPA Bhopal. On behalf of the organizing team, I extend our sincere thanks to him for sharing his insights on climate responsive strategies and net zero energies building design. Dr. Arora talk was structured around two major themes. First, he touched upon climate responsive design, where he walked us through climate classification and how it's guided appropriate design responses, the use of psychometric chart to access thermal comfort and define strategies where conditions fall outside the comfort zone, the challenges of dehumidification in Indian context, passive active strategies such as internal heating, passive solar heating, and active solar systems in hilly regions, and importantly, the role of tools like sun path diagram in optimizing solar access and shading. The second half of his talk focused in greater detail on net zero energy buildings design, where he introduced the concept of solar envelope, a volumetric constraint that ensure a building does not overshadow its surroundings. He demonstrates how this principle encourages buildings from that are allowed maximum solar access, helps maintain the natural daily rhythm of sunlight for heating and lighting, supports surface articulation like pyramidal or stepped form that maximize terrace area for solar harvesting, and challenges conventional repetition in form while improving environmental performances. He emphasized that 75% of direct normal irradiance is received between 9 a.m. to 3 p.m., making design decisions within this window especially critical for both solar gain and comfort. The session concluded with some interesting reflection on the practical challenges of solar envelope design in composite climates, where maximized heat gain may conflict with the cooling needs. We thank Dr. Sandeep Arora for this rich and layered session that merges science from and sustainability. We also thank all participants for your attention and engagement. Please join us again tomorrow for our afternoon session at 11:30 or 2. Thank you. A great evening. And thank you so much, sir.
Thank you very much. Thank you all the participants for wonderful questions. Your questions gave me a substantial amount of thoughts. So I'll reflect on it and I'll try to incorporate more details. But wonderful questions were asked today. So thank you, Shubham, for inviting me. And thank you all the participants for very good questions. Thank you.